Okay, I'm sorry that I forgot to record the today's session in the morning, um, but I will try to make some key points summary. Okay, so you have this absolute value. Okay, what will you do this with this absolute value? If you have absolute value of x less or equal c, you can expand this x into minus c less equal x less equal c. Okay, if you have um, absolute value greater than c or equal, okay, this means you have it's actually negative c greater than or x less than equal negative c or c less or equal x. Okay, so it's having the same expression as this c. Okay, and okay, so you need to change the um, less or equal into uh, greater or equal. Okay, so if you are dealing with absolute value, you have two possibility. One is when x is negative, and the other when x is positive. Okay. So when x is positive, then we just need this expression, right? And when it's as x is negative, then you multiply all negative. So you change the this sign. Okay, so greater become less. Okay, so as in our example here, x minus 5 less than 2. So x minus 5, we have two components here, the positive one and negative one. So I have positive and negative. Okay, so positive, we will have just x minus 5 less than 2. But when we have negative here, less than x minus 5. We solve both x here. So we have the interval is from 3 to 7 in an open interval. Okay, this is the solution. So we can write the solution 3 to 7 in open interval. Same thing here. If you have 3x plus 2 in absolute value greater or equal 4, then first this is the positive one, and you get the x greater than equal to over 3, and then less than negative 4, this is the negative one. So you have x equal or less than negative 2. So this is your solution. X less or equal negative 2, x greater or equal to over 3. Or you can write in math in interval. Okay, okay, that's the some idea for absolute value. And I think we also discussed functions. Okay, so if I have these two conditions here, a and b, a, it's in a set of a, we have an element of, let's say, our inputs. We can say it's x, and b as our target. Okay, so this is the first case, and this is the second case. Okay, as you can see, in the first case, there are two inputs from a going to the same direction in b, while in the second case, from one element a goes into two element in b. The function is on the first case, okay, where the element of in the set of a, they assign so a to be here. If they have the same element in b, that's not a problem. But it will be a problem here when one element of A here, they become 2 in B. It's not the functions, okay? So the rule will be function, okay? The rule that assign each element, we say it's x, okay? In a domain, it's our A, okay? Exactly one element, f of x. In a set of B, we call it range, okay? So one element of x cannot have two element B. It must exactly one element A to B. Okay. Okay. To give you a glimpse of what range or domain is, let's see here. Okay. We see our simple function here, x squared plus 4. Of course, if we see and try all possible number of x, we can say that all x is possible in real number. So we can say that all x is real number, or x is element of real number. But for range, okay, we see it has plus 4. So everything need to plus 4. So because it is squared and all must be positive when we plug in into this x, which means if you have negative, it will be positive. If you have 0, it's 0. So you have at least 4 at our range. So your range here, in this case, in the functions, you need to have at least 4. So greater or equal 4. Or you can say 4 close interval until infinity, open interval. Okay. And then there are order of operations. Okay. In the algebra, we have order of operations. So you need to check whether the algebra operation has parentheses, exponent. You need to going in order. Okay? And if you have seen the same, like for example, you have multiplication, division, all the same thing, then you need to go from left to right. So when you see this number here, okay, 6 minus 1 multiplied by 0 plus 2 divided by 2, as in algebra operations, and number B, 60 divided by 5, 7 minus 5, parentheses, right? So guess what the answers will look like. Okay. For number A, you may think 6 minus 1, 5, and then multiply by 0, 0, plus 2, 2, divided by 2, is 1. You may think like that. But remember, because we have our order of operations, okay, we need to have this in order to solve any algebra operations. So see here, this is having multiplication, this having division. So we need to do that in order. So because we have multiplication and division in the same algebra operation, we go from left to right. Okay. So we go from 1 multiplied by 0, it's 0. And 2 divided by 2, it's 1. Okay. So we go from here, 6 negative 0 is 6 plus 1, so it's 7. So this is the correct answer. Okay. Number B, 60 divided by 5, and then parentheses, 7 minus 5. You can check my or all of this solution to wolframalpha.com, and just plug in this whole equations, operations. Okay. You can also use scientific calculators and see what you've got there. Okay. Some of you trying to, okay, it seems we can minus this and multiply this with 2, 5, 2 is 10, then 60 by 10 is 6, question marks, okay. Is it true? So if you check Wolfram Alpha or using your scientific calculator, you see the answer is 24, okay, because this is actually having parentheses here. So you need to take that parenthesis, so 12, and then 7 minus 5, it's 2. So the answer will be 24. Okay. So I want you to at least remember this order of operations. The easiest way to remember, you can remember the PEMDAS: parentheses, exponents, multiplication, division, addition, subtraction, and if same precedence, you're going from left to right. Okay. Okay. Another thing. Here, I think last week I did some mistake. Okay. So I giving you this equation and I solve it as though as this is a positive one. So if this is positive, this sign here positive, you can solve it. You can find the real number. But if you still have this negative here, so you can see this is squared. You go 3, 4 here, 3 going to over here, it's become 1, so it's negative. So I multiply all by negative. You see here negative 1. This is trouble. But no, mathematicians say that we can say that from here we go for another plane in our numbers. It's called the complex numbers. So if we thinking or looking back at our logical numbering from our algebra operations, like for example here, I have all of sets of algebra operations here. X minus 5 0, x plus 2 0, 2x minus 1 0, x squared minus 5 0, x squared plus 1 0, and try to find the solutions. Okay, from first one you go x minus 5 is 0, so x is equal to 5, and this is, we can dive in this is our natural number. Okay, our natural number. And then if we have x plus 2 is 0, we have a new number with the negative sign. It's in the integer world. Okay, we call that integer. It's like a z here. It's from Zahlen in Germany. It is actually counting the meaning. Okay, and here 2x minus 1 is equal to 0. We have the fraction, and our numbers here is quotient. Okay, and we have x squared minus 5 equals 0, and we can solve this plus minus square root of 5. We know that square root of 5 it has a lot of numbers if we try to find the decimals. Okay, that's actually called the irrational number, irrational, and the whole set numbers of that rational and irrational, we call that real numbers. Okay, so that is a little bit history about our numbers. Okay, we start from the natural numbers that we find in nature, like we have discussed before. Like you have an apple, and you add one more apple, it becomes 2 apple, 3 apple, or maybe orange, 2 orange, 3 orange. Okay, and then you find what if you subtract and you find a negative part, or you find the negative tools. Okay, to subtract, and you find the new number, the integer, which including the negative parts. And you have the fractions, okay, when you are dividing, maybe dividing a pizza, okay, from one pizza you divide, become 8, 9, 10, okay, and those are quotient, the fraction, okay. And then you find the real number, and then there are another new number after the real number. So this is x squared plus 1 equals 0. You want to try find a solution, but you are stuck here. What is the square root of negative 1? And because this is actually getting stuck, okay, when most of mathematicians getting stuck here, and they found, or they developed, okay, this is an identity, this is a new identity, it's called the I, or imaginary number. Well, it's not really imaginary, it's the naming that makes the identity imaginary, okay. And they are the complex numbers, a new set of numbers called complex, okay. And we go for our fundamental theorem of our algebra. So all or any polynomial that have complex coefficient will only have complex roots, okay. So for example, okay, if you have learned quadratic function, you will know that sometimes when you are trying to use some quadratic formula, if your quadratic functions is not really easy to be factoring, then you are using quadratic formula. Sometimes you're getting some number here, but some case maybe you get negative, okay. In our complex here, our complex number, we can write down this negative 3 becomes 3 plus minus 3 and giving I, okay. So we have at least this part and this part. This part is our imaginary numbers. This part is our real numbers, okay. If we say here in complex arithmetic, okay, usually complex start with z and x, I, y, where x and y all real number, okay. So this is real part, this is imaginary part. This is written as re and then z, and this is I am z. It's imaginary, it's real, okay. If the real part 0, then z, the total whole z will be imaginary. If imaginary, the imaginary part is 0, then the functions or the z is actually real, all real, okay. So example, we have 5 plus 3i. So this is real, this is imaginary, okay. So you can write also rez 5, I am z 3, okay. You can write that also. And in complex plane, you can also pinpoint your solution there, okay, your z, okay. So this is the real part, this is the imaginary part, okay. So if you have z, 5, and 3i, and this is your z. If you have other z or other symbols that in this complex plane, for example here, negative 2 plus 2i. So negative 2 here and 2i here. So it's going here, okay. So that's for complex arithmetic, okay. We will not discuss beyond like this advanced mathematics level. We will just scratch the surface for the complex, okay. I hope you get the idea for the complex, okay. Okay, so we dealt with functions, and I'll try to find this domain here, okay. Try to find domain, and see you on the next class.